Let me ask you something. You're walking through the grocery store, and there are two cartons of blueberries. One is deep, almost navy blue. The other is lighter, with a hint of red. Which one are you reaching for? I'm going to guess most of you grabbed the darker one, and honestly, the reasoning feels bulletproof. Darker means more anthocyanins. More anthocyanins means more nutrition. It just sounds right. But here's the thing, that logic is only half true. And in the next few minutes, I want to show you something surprising about the color blue on a blueberry, because it turns out that blue is not what it seems. It's a visual illusion, created by chemistry and physics working together. And once you see it, you'll never look at a carton of blueberries the same way again. Okay, let's start with the half you got right. Blueberries really are packed with anthocyanins. These are a big family of plant pigments, and they're responsible for a lot of the reds, purples, and blue purples you see in fruits. Lab studies have shown that anthocyanins are an important contributor to blueberries' antioxidant activity, not the only contributor, but a real one. So yes, blueberries are nutritious. And yes, anthocyanins play a role in their color. That part checks out. The problem is the shortcut we take. We look at a blueberry and think, darker color, more anthocyanins, more nutrition. But there are several steps missing in that chain. Different varieties of blueberries have different types and amounts of anthocyanins. Some varieties are naturally dark, but they might not have the highest total phenolic content. Some lighter varieties can have surprisingly strong antioxidant activity. And even on the same bush, berries at different stages of ripeness look different. Then you add storage time, handling, and all sorts of variables, and the color changes again. There's also a difference between composition and effect. Just because a lab test measures a high level of a particular anthocyanin doesn't mean your body automatically gets a proportionate health benefit from eating that fruit. Antioxidant activity can be measured in different experimental systems, but it's not one fixed number that stays the same, no matter the conditions. So here's where we land. Color depth can be a clue, but it's not a nutrition meter. When you're judging a blueberry by eye, you're actually grading light, not grading molecules. Now some of you might be thinking, fine, maybe you can't compare across varieties, but in the same carton, picking the darkest one has to be the move, right? And honestly, that logic holds up reasonably well within the same variety at similar ripeness. As fruit matures, anthocyanins accumulate, and color does tend to deepen. But there's a loophole, and it's hiding in a detail you see every single day, but probably never think about. You remember that whitish, dusty coating on blueberries? A lot of people assume it's dirt, or maybe pesticide residue, something to scrub off, and so they wash those berries aggressively. But that white coating has a name. It's called the wax bloom, and it's not dirt at all. It's a natural waxy protective layer that the blueberry produces itself. Here's where it gets interesting. If you gently wipe that wax bloom off a blueberry, something happens. The blue color fades noticeably. And underneath, you start to see a deeper, more reddish purple tone. Think about what that means. The blue you're seeing is not just the color of anthocyanins inside the fruit. That surface wax is helping to create the blue. It's kind of like putting frosted glass over a purple piece of paper. Looking through the glass, the color seems different, but the glass itself isn't dye. What you're perceiving as blue is partly an optical effect created by light, and that brings us to the real question at the heart of this. Where does the blue on a blueberry actually come from? To answer that, we need to take the blueberry's color apart layer by layer. The first layer is chemical. Inside the blueberry skin, you got anthocyanins, and here's the key detail. By themselves, anthocyanins are actually red-purple. You can test this yourself. Squeeze a blueberry and let the juice run out. Is it blue? No, it's purplish red, because the pigment itself is reddish-purple. It absorbs certain wavelengths of light and reflects others, creating that base color we see in the juice and the crushed skin. But here's the thing. If all you had was that chemical layer, a blueberry wouldn't look all that blue. The pigment alone gives you a dark reddish-purple, not true blue. So to get the blue, you need a second layer, and that's where physics comes in. The second layer is physical. That wax bloom on the surface of a blueberry is not a smooth, glossy film under a microscope. Scientists have found that it's made up of countless tiny wax structures at the nanoscale. The surface isn't uniform, and the structures aren't arranged in a neat, regular grid. When sunlight hits those tiny structures, something interesting happens. Scattering different wavelengths of light get scattered to different degrees, which makes the reflection of blue and narrow ultraviolet light more prominent. At the same time, the darker tissue underneath absorbs a lot of the other colors that don't get scattered back out. Put those two layers together, and here's what you get. The bottom layer provides a dark, reddish-purple base. The top layer uses its physical structure to alter how light scatters, and the result is that a stronger blue signal ends up reaching your eye. That's why a blueberry looks blue. It also explains why, when you wipe off that wax, the blue weakens. The anthocyanins are still there, you didn't wipe those away, but you removed the blue filter, so the underlying red-purple or deep dark color becomes more visible. This is the key to why the blue on a blueberry is a double truth, created by both chemistry and physics. It's not just about what's inside the fruit, it's also about what's on the surface. Now let me be careful here. This doesn't mean the wax is a blue dye, and it doesn't mean all structural color works through the exact same mechanism. Structural color isn't color without pigment, it's about how microscopic structures select and organize light, and that organization is just as important in determining the final color you see. Researchers have shown that when the wax bloom is removed, or when the surface is treated with certain solvents, or when the optical interface is altered, the blue appearance fades. Meanwhile, simply contacting the berry with water doesn't produce the same effect. NISA-controlled comparisons tell us that the blue isn't just a chemical answer hidden in the fruit. It's the result of pigment, structure, light, and viewing conditions all working together. You can see similar principles in nature in bird feathers, butterfly wings, even the blue sky. But each of those relies on different specific structures and physical processes. They're useful examples for understanding how structure can influence color. But we can't lump every blue in nature into one single formula. So back to the original question. Are bluer blueberries more nutritious? My honest answer? You can't tell by the depth of the blush. Fawn berries are nutritious, and that nutrition is related to anthocyanins and other polyphenols. That's true. Anthocyanins are also part of the blueberry's color foundation. Also true. But the blue itself is not a label you can read for nutrient content because part of the blue you're seeing comes from the nanostructure of the wax bloom. It's a result of light scattering, and that has nothing to do with nutrition. Some very dark blueberries do have higher anthocyanins, but some lighter ones can be just as nutrient-rich. Variety, ripeness, storage conditions, even the light and angle you're looking from, all of that shapes the signal your eye receives. So if you want practical advice for buying blueberries, here it is: don't obsess over color depth. A berry with an intact wax bloom tells you the surface wax layer hasn't been obviously removed. That's all it really tells you. For freshness, you need other signs: firmness, plumpness, smell, and checking for any signs of mold. But I'd also like to leave you with a thought. Blue is actually a remarkably rare color in nature. Blue flowers, blue fruits, blue bird feathers, a lot of them aren't produced by a single pigment. They're created by structure and light working in partnership. Blueberries are exactly that kind of marvel. They use anthocyanins as their base and wax crystals to reshape the scattering of light, and the result is that beautiful, hazy, dusty blue. So the next time you bite into a blueberry, I hope you're not just eating a fruit. I hope you're also savoring a tiny miracle of chemistry, physics, and light. Thanks for watching.